Okay, so we're starting our new unit, which is all going to be systems of equations. We've already done system of inequalities, but in general, a system of equation is just two or more linear equations. Okay, so it's going to be two equations. In general, the solution is the ordered pair, so x, y, at which the lines intersect. And there are three possible solutions that you could see. Okay, so the first type of solution is one solution. So let's say, okay, so if you have one solution, it's because you have intersecting lines. And this is what that would look like. So you have your x and y coordinate grid, plane. Here's one graph. Here's another graph. Your solution would be the point at which they intersect. So it would be this point, x, y. That would be your solution. So that's one solution. Another way you could see is no solution, or another type. So no solution, if you look at your x and y grid, would be this one. And then if one solution was they intersect, so wouldn't no solution be they never intersect? So they never intersect. And the only way that they cannot intersect is if they have parallel lines. So they are parallel, which means they have the same slope. So same slope, but different y-intercept. They're not the same line, but they do have the same slope. And then lastly, we could have infinitely many solutions. What that would look like is we take our first equation, and then we have our other one, and it's right on top of it. So the only way that that could happen is if they are identical lines, which means they are the exact same line. Remember, we could always use our little infinity sign. Okay, so let's get to actual examples. Example number one, you always want these in slope-intercept form because we are graphing the line. So for the first one, my y-intercept is -8. 1, 2, 3, 4, 5, 6, 7. So -8. My slope is a +1, so I go up 1, over 1, down 1, over 1. If you do not have a straight edge, it's very, very important. Also, I would encourage you to keep on going because this is going to matter. So I'm just going to keep on up 1, over 1, up 1, over 1, up 1, over 1, all the way. And you'll see why this is important later. Connect my dots. Go to the next one. Y equals my y-intercept is a +1. My slope is -2 over 1, so I go down 2 over 1, up 2 over 1. Now see, I want to keep going because I don't want to guess where they intersect. I want to keep on going with my slope until they definitely hit until they definitely hit a point. Now that they've connected, or now that they've intersected, I'm just going to go ahead. I'm not going to keep on going. So my solution is this point right here of where they both intersected. So I would say my solution is the point x, which is 1, 2, 3, it looks like. And I went down 1, 2, 3, 4, 5. So -5. That is my solution. Next one. All right, I've got to take that top equation, and I've got to put it in y equals mx plus b. So I subtract x. 3y equals -x minus 15. Divide everything by 3. Leaving me with y equals -1/3 x minus 5. Right, because that's a 1. Okay, so now we're going to go ahead and graph that. My y-intercept is -5. 1, 2, 3, 4, 5. And my slope is -1 over 3. So I go down 1, 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. Connect my dots. Okay. The next one is y equals -7. So I go to the y-axis to 1, 2, 3, 4, 5, 6, -7. You got to think hoi vux. This is a y, so it's a horizontal line. So side to side. This time, I go ahead and I look at where they intersected, and it's right there. So my solution is that point. And if I look, it looks like to me 1, 2, 3, 4, 5. I go over 6, and I went down 1, 2, 3, 4, 5, 6. I went down 7, so -7. Okay, next one. All right, got to take that top one, put it in y equals mx plus b. Subtract x. Divide everything by 2. Put your 1 there if you need to. Y equals -1/2 x plus 2. 4 divided by 2 is 2. I graph that, go to +2. That's -1 over 2, so I drop 1, go over 2. 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 Opposite. Up 1, left 2. Up 1, left 2. 1, left 2. Up 1, left 2. Up 1, left 2. Okay, connect them. All right. Now I go ahead and I graph my other one. Y equals -1/2 x plus 2. I go to +2. Down 1 over. Oh, wait a second. Oh my lordy. Is this the same thing as this? Yes. It's the exact same line. So since this is the exact same line, my solution is infinitely many, or you could put infinitely many solutions. Okay? One more. All right, I take the first one. Lucky for me, that's already in y equals mx plus b. So 1, 2, 3, 4, 5. My slope is 1, so up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. And now I do the opposite. Slope of 1 is really easy because it's pretty much just diagonals. Connect them. I have to take this one and turn it into slope intercept, so I subtract x. Divide everything by -1. So y equals negative divided by -1 is just 1, so just x. And then 2 divided by -1 is -2. So my y-intercept is -2, and my slope is 1. And I know you already know what's going on, but just so we know for sure, they don't look like they're ever going to intersect, but to prove that they are not, our slopes have to be the same. So for our first equation, the slope was 1. The second equation, the slope is 1. And then we have different b's, different y-intercepts. Therefore, our solution is no solution. Okay? Now you can also check these in your graphing calculator. All you would do is, grab, wait, that's not what I wanted. Sorry guys. Where is my graphing calculator? Here it is. All you have to do is you could just, we're going to go more into it in class, but you can at least check yourself. If you go to y equals, so let's go back to the very first one that we did. You would put in y equals x minus 8. And then for the y2, you would put in negative 2x plus 1. And then you could graph those. Now remember, if you get to this weirdo thing, it's because you still have your scatter plot on. So you need to take your scatter plot off by going to stat plot, turn it off. And then we also want to get our window back to normal. So we zoom 6. So then there's our first one. There's our second one. There we go. Okay, and then we're going to talk in class about how you actually find that point, that exact point. But for right now, I just want you to try to do it manually, and then we'll talk about that later. Okay? Here are your practice problems. Go ahead and write those down. When I check your practice problems, I should see 4 completely separate equations, or 4 graphs, and then also the solution.